do, but okay. The wrong title on my video, I'll change it later. Alright, so today we're reteaching, or I'm reteaching part of 5-7. I'm going to review part of 5-6. Remember I told you that on 5-7 on these 4 problems, 5, 6, 7, and 8, I only did part of the problem and we need to finish it. So example 5, 6, 7, and 8, and that's on your pink sheet. Alright, so we're going to start, it says find the range of the possible values of x. So your final answer is going to have look something like this. In order to get this, we have to write 2 inequalities. We have to write 2 inequalities. It's a little bit different depending on if the x is part of an angle measure or the x is part of a side measure. Similar, they both start out very similarly. So for example 5, we wanted to find the possible ranges of x here. So we know we're going to have a final answer where we fill in these 2 blanks. But in order to do this problem, to do these kind of problems, we need to remember that the range of possible angle measures is greater than 0 and less than 180. Okay, so that's going to be something that helps us write our second inequality. We need to remember this to write our second inequality when we're talking about angle measures. This is not the same as when we're talking about side measures. So you with me, Leslie? Does that make sense so far? We know the total number of angles in a triangle is 180, right? So all of the measures of the angles inside the triangle, the interior angles, have to be somewhere between, not including, 0 and 180, right? So the first, we're going to write 2 inequalities. The first one is going to be just like I did on the notes, the first part. So this angle, how does it compare to this angle? We've got 2 congruent sides and their included angle. Since there's 2 congruent sides and their included angle, these side measures are different. We can compare them based on these side measures. So the side across from 5x plus 2 is 6. The side across from the other included angle is 5. Since 6 is greater than 5, now I know that 5x plus 2 has to be greater than 67, Jonathan. Does that make sense so far? Alright, so this is what we put into originally. So subtract 2 from both sides. 5x is greater than 65. Divide both sides by 2. And now I know that x has to be greater than 13. Well, the greater than limit, so we need a lower limit and an upper limit. The greater than is the lower limit. Seems like the opposite of what you think. This is x is greater than some number. So x has to be greater than 13. So since this was a greater than, now I need the less than, right? If I need a less than, then I'm going to go back up here and use this range. I've already got my bottom range, it's 13. I need my upper range, my upper limit. So my next inequality is going to be the 5x plus 2, but now we know it has to be less than 180. That's always going to be our second inequality, if this is a greater than. If this were a less than, this inequality would be 5x plus 2 is greater than 0. Does that make sense, Chidi? Alright, so the reason why I put less than 180 here is because I already had my lower limit. The lower limit goes with greater than 0. The upper limit goes with less than 180. Subtract 2 from both sides. Divide both sides by 5. And that's 35.6. So my upper limit is 35.6. Does that make sense? Sorry?
Will they always have a decimal second component?
They don't have to. You could leave them as a fraction as well. Sometimes they're going to be repeating decimals. If they're repeating decimals, just leave them as a fraction. On your worksheet today, a lot of the answers are going to be repeating decimals, so just leave them as an ugly, improper fraction. All right. Now this one has to do with the side measure. So I'm about to cheat a little bit for you. You want to cheat? So the cheat is if, are you ready? The only kinds of these problems we're going to do, Phoenix, the only kind of problems of this we're going to do for the side measures is when the side measure is less than the other side. It's possible to write a range of values the other way, but we cover that in honors here in geometry. So you'll see all of your problems should have, if you look, this 2x minus 4 is across from a 95-degree angle. 32 is across from a 106-degree angle. So 95 is less than 106. Which reminds me, cross out number 7 on your worksheet because we're not doing that one because the angle measures are not right. Cross out number 7.
Oh, which is the pink one or the white one?
On the white one, your homework. Thank you for that distinction. On your homework. And then on number 4, you got to fill in the letter M. So the letter M is in between L and N. The letter M is at the end of segment P. So on number 4, y'all listening on number 4? The other end of that P is the letter M. So this is a quadrilateral PNML. Does that make sense? We're crossing out number 7, and we're putting the letter M on number 4 because it asks you for an angle LPM, but there's no M on that diagram. Did you put it in everybody feel comfortable you put it in the right spot? Okay, so let's go back to this example. So now we know that this side is less than the other side. So now we're going to write that inequality. 2x minus 4 is less than 32, and we're going to solve that. So this is our first inequality. Add 4 to both sides. 2x is less than 36. Brooks, you following with me? Divide both sides by 2, and x is less than 18.
So we're only going to take the inequality is
Yeah, but all of yours will be on the test, right? And on your homework now that we've crossed out number 7. All right, so this is where our final answer is going to go. This is x is less than 18. X is less than 18 has to go here. So here's another little cheat. Since they're always going to be less than, your next inequality, only for the side measure ones now, it's different for the angles. This one is always going to be greater than 0. Whatever the algebraic expression is, greater than 0, because the side measures have to be a positive number, right? So anything greater than 0 is a positive number. Does that make sense, Diana? Does that make sense, Caitlin? So for if the x is part of the side measure, you're always going to have an inequality that says that algebraic expression is less than the other side, and the second inequality is always going to be that algebraic expression is greater than 0. Okay? Where here, the second inequality is always going to be greater than 0 or less than 180. It depends on what the first one is, because we need one of each. All right? Does that make sense, Brooks? Okay. So now we solve this one. Add 4 to both sides. Divide both sides by 2. And now we know that x is greater than 2. There is no greater than symbol there, right? But if we read this the other way, x is greater than 2, right? X is greater than 2 and x is less than 18. Does that make sense, Leslie? And that's our final answer there. Are you with me? Any questions so far? Okay. This is another side measure one. So what's the second inequality going to be? Greater than 0, right? So 5x plus 2, it's got to be greater than 0. But let's write our first one first. So congruent side, included angle. Congruent side, included angle. So this goes with 55 and this goes with 47. So 55 is less than 47, so 5x plus 2 is less than 60. Oh, I did it wrong, didn't I? Thank you, Brooks. That's not 47. That's 55 is less than 68, because this is what we're using to pick our inequality, but that's not the numbers we're using in our inequality. Do you see my mistake, Nick?
Yeah.
Okay, does it make sense now?
Yeah.
Okay. So I've got to fix that in my inequality. It's not 65, it's 47. And now I'm going to solve. 5x is less than 45, and divide both sides by 5. X is less than 9. So my final answer is going to be this range of values. X is less than 9, that goes here. My other inequality is 5x plus 2. I got myself flustered this morning and I thought that, oh wait, that can't be a negative. But it can be a negative because we're not talking about the side measure here. We're talking about x, and x is going to be plugged into this expression. So first time I looked at it today, I'm like, wait, that can't be right, but it is right. 5x is greater than negative 2. Divide both sides by 5, and x is greater than negative 2/5. So if we plug negative 2/5 in here, that side length is not going to be negative, but the x is negative. So that is our lower range. Any questions on number 7? Phoenix, why are you facing that way, Ben? Let's not turn back around that way. All right, example 8. The x is in the angle measure, right? Congruent side, the included angle is this expression. The included angle in the other triangle is 65. So the side across from this angle measures 11. The side across from this angle measures 9. Now it's okay to have a greater than here because we're talking about the angles, right? 11 is greater than 9. 6x plus 15 is greater than 65. I'm going to go ahead, so that's our first inequality. Subtract 15 from both sides. 6x is greater than 50. Divide both sides by 6. And x is greater than 8.3, repeating. You could also leave it as an improper fraction. 56 is x is greater than 25 thirds. I probably prefer that you did that, but I'll take it either way. So if it's greater than, it goes in this first spot. X is greater than 25 thirds. So what's the second inequality going to be? Do I need a greater than or do I need a less than? I need a less than, right? So it's going to be less than what?
180.
Yes, since this is an angle one, we use 180. On the side ones, we never use 180. I'm going to subtract 15 from both sides. 6x is less than 165. And so x is less than 27.5. So that is our upper limit. It's going to be between those two numbers. Any questions? All right, and now we're going to go to the back side of that page. You guys caught up with me? Need to wait a little bit longer? All right, so let's look at this one. So this is just like the one we went over with, I forget who I went over this one with. David, did you ask for this one? Something like this? Anyway, never mind. Let's just do it. Example 5, determine which side is the shortest in the diagram, but they don't give us any side lengths. So how can we do it if we don't know the side lengths? We're going to use that trick. So that's what we're doing now. We're going to use the trick. So go ahead and write the trick again, and we're only going to write part of it. The trick is in one triangle, assign random side lengths based on the measure of the angles. And then we're going to use those in the second, but I'm just want you to remind yourself what the trick is. You should have all of this in your first notes. The back side. Yeah, we're going to rewrite. That's why I'm not making you rewrite all of it. But we are going to rewrite this trick part, the first part of the trick. Before we can do the trick, though, we've got to make sure we know all three angles. If we know two angles in a triangle, we should be able to find the third, right? I'm going to let y'all catch up. So how can I find the third angle in triangle DBD? Brooks?
Add both up and then subtract it from the
Right. So add 95 and 40, you get 135, subtract it from 180. Now we know that this side is 45. Here we're going to do the same thing, but here 48 and plus 47 is 95. If we subtract that from 180, now we know that this angle is 85. So we start in one triangle. We are going to do both triangles this way, but this is how it starts. Okay, so we're going to start by looking at the three angles in one of the triangles. I always start with the biggest angle. So 95 is bigger than 45 and 40. So I'm going to go ahead and the side across from the biggest angle, I'm going to assign the number 15. Segment BC or side BC is not 15 units of any sort long. I have no idea what it is. But since it's the biggest side, I'm going to assign it 15, and the other sides have to be smaller. So the next biggest angle is 45, so I'm going to assign it, the side across from it, 14. Just go down one. The side across from the smallest one is BD. So I'm going to go down one more from there because it's going to be smaller than both the other two. So I'm going to say that this side BD is 13. And I'm going to remind myself that BD is congruent in both triangles. So if it's 13 in this triangle, it's got to be 13 in this triangle. So far, so good? Okay. So now, I'm not looking for the biggest angle. Now I have to start with, okay, 13 is across from an angle that has a measure of 48. How does 48 compare to the other measures? Well, 48 is bigger than 47, but smaller than 85. So I'm going to go ahead and draw my arrow across to the side across from the smallest angle. If 48 is bigger than 47, and the side across from 48 is 13, I'm going to go down one and make that one 12. Does that make sense, Chloe? And now I've got one more angle to assign a value to, and this angle is the biggest angle in this triangle. So the smallest is 12, the middle is 13, so I'm going to go up one and make AB 14. These are not the measures of these sides, right? These are just how we're comparing them. So now we don't know how long AD is, but we know it's the shortest one. If they ask us the longest one, it'd be the biggest number. The shortest one's going to be the smallest number. The biggest one's going to have the biggest number. So we know that BC is the longest side. it asks for the shortest stub, but it could ask you for either one. DeMille? DeMille? You're supposed to be writing what we're writing, buddy. Put your arms in your sleeves, DeMille. Pick your pencil up. Alright, that's all I have for you. You can look on your worksheet for the last few minutes. Yeah, you can go ahead and scan and submit that.
What about, what is this? Oh, it's just the homework?
Yeah, I didn't print it both sides. Yeah. Yeah. You're welcome.
That helped a lot. That day was the one I missed, I think, too.
Oh, okay. Thank you for saying that, Brooks. I feel like I